Hey everyone, and welcome back to DevOps Corner. If you're into all things DevOps and Kubernetes, go ahead and hit that subscribe button. And give this video a like. It really helps the channel out. All right, today we are diving into something that I'm sure every single one of us has seen and probably cursed at our screen about. Let's get into it.
So, you've just pushed your new deployment. You run kubectl git pods, and bam! There it is, CrashLoopBackOff. It's that status that can just send a shiver down your spine, right? But what is it actually telling you? It looks like this big, scary, critical error, but really, it's just Kubernetes' way of trying to send you a message.
Okay, so to really get it, you gotta know how it all starts. And honestly, it begins with something super simple. You've got a pod, just chugging along in your cluster, doing its thing, and then poof, it crashes. The container inside just stops. Now this could be for a million reasons. A bug, a bad config file, it ran out of memory, literally anything that makes that process just die.
Now here's the thing about Kubernetes. It's built for resilience, for high availability. It's not just going to see that dead pod and go, oh well. Nope. It has this built-in rule called a restart policy. And the default setting for this is always. And yeah, it means exactly what you think it means. If a container kicks the bucket, Kubernetes is going to jump right in and try to restart it to keep your app alive and kicking.
So Kubernetes is trying to be a good teammate, right? It restarts the pod. But what if the thing that killed it is still there? Think about it. Let's say you just pushed out a brand new deployment, but whoops, there's a nasty bug in the code. Maybe some exception gets thrown the second the application tries to boot up. Well, that pod is never, ever going to start correctly.
And that's how you get stuck in this brutal loop. You can see it right here. The pod spins up, the buggy code immediately throws a fit, the container dies, and the whole pod crashes. Then Kubernetes, just following its always restart policy, dutifully brings it back online, only for it to crash again for the exact same reason, over and over. This is the crash loop part of the name.
But, Kubernetes is pretty smart. It's not just going to sit there and mindlessly restart a failing pod 1,000 times a second. It sees this pattern, this loop, and it realizes, hey, just instantly restarting something that's doomed to fail is a total waste of resources and it's not helping anyone. So instead of just hammering the system, it does something else. It adds a delay.
And this delay is the whole back-off part of the puzzle. It's not just any delay either. It gets longer each time. So after the first crash, KS might wait, say, 2 seconds. After the second crash, maybe 10 seconds. It's what we call an exponential backoff. The delay keeps growing with every single crash, all the way up to a cap of about 5 minutes. And this is actually super helpful. It gives you, the human, time to notice there's a problem and start digging in, without the system just melting down.
So, let's put the two pieces together. When you see CrashLoopBackOff, what Kubernetes is telling you is that a pod is stuck in a crash loop, and because of that, it has started applying an increasing backoff delay between its restart attempts. See? It's not the error, it's the status report on the whole situation.
And this right here is probably the single most important thing to understand. If you only remember one thing from this whole explainer, let it be this. CrashLoopBackOff is not the problem. It is not an error you can fix. It's a big flashing signpost telling you that the real problem is somewhere else, deep inside your pod.
I love this analogy. Think of it like a fever. A fever isn't the actual sickness, right? It's just a symptom that tells you your body is fighting off an infection. CrashLoopBackOff is the exact same thing for your application. It's the symptom, not the disease. It's the signal, not the error. Your job isn't to fix the signal, it's to find the root cause.
So yeah, trying to fix CrashLoopBackOff is, well, it's impossible. You got to put on your detective hat. The real solution is all about figuring out why your application is crashing and then fixing that underlying issue. It could be in your code, your Docker file, your YAML config, somewhere.
So where do you even start looking? Well, here's your checklist. Your first port of call almost always should be the logs. Just run kubectl logs on that failing pod and see what it spits out. 9 times out of 10, the answer is right there. If not, your next step is kubectl describe pod. This can give you clues about other problems, like maybe you've hit your resource limits. From there, you're digging into your deployment files, looking for typos, or maybe it's time to look at the application code itself. This is where the real investigation begins.
So, the next time you see that dreaded CrashLoopBackOff status, don't panic. Don't just start throwing random changes at it. Just take a breath and ask yourself this one question. This isn't a dead end. It's the start of your investigation. It's a message. What is your crashing pod trying to tell you?
And there you have it.
That's the whole story behind CrashLoopBackOff. I really hope this helps you track down those pesky bugs a little faster next time. Thanks so much for watching. If you found this useful, do me a favor and hit that like button and share this with your team. And of course, subscribe to DevOps Corner for more explainers just like this one. See you in the next one.